I'm actually gonna try to cover a lot of stuff. So let's see how much I get through. So one of the two, I would say two of the biggest things I want to cover this time is RxJS, RxJS plus React hooks. Like how do you wire that up, and what are some sensible ways of connecting these two technologies? And then another main topic is going to be cancelable requests. Okay, so those are what I'm gonna just start with a very small example for RxJS. I think that is, well, it says, so that's this example where there's a counter, you can count the thing up and down, and this is a very basic example you see with React hooks, but I'm doing it with a behavior subject, I believe. So let me open that up. Okay, so this is what the code looks like for this example. So I have this behavior subject created here on the sort of top level scope, on the global scope sort of, and then we're using a use state to temporarily sort of cache the current result from the behavior subject, and this is just a way to put it into the React hooks sort of repository of objects or of values. And then using this use effect hook, we subscribe to this behavior subject, and then we make sure it's cleaned up here by returning this cleanup function. Okay, and as the dependency, we're saying we're dependent on this count, which isn't super important right now because it never changes. But if we're gonna make this into a reusable hook, then the dependency array will matter. So how would we make some? And when we want to change a value in this behavior subject, we just call .next, like you normally would with RxJS.
Hey,
yeah.
Toby, I have a question.
Mm-hmm.
So, are you using? I'm looking to your code. You're using set value only in the use effect hook. You're not using it in the button click.
Oh, correct. Should I use set value here? No, because I actually want the value to go through the behavior subject. And why is that desirable? Because this behavior subject might be watched by other parts of the application conceptually. Like this might be passed into another component that's also watching it. So if I channel the results, the values through this behavior subject, then all the places that watch this guy will get updated.
Right.
Whereas this value, this use state value, is just a temporary cache for the current value of this behavior subject for the purpose of only this component, and so that this changing of the value can notify React to re-render.
Right, and to be clear, because I'm just not as familiar with React, this use effect is only going to run once, right? Because of the second argument you're passing on line 14.
It will only run once if this array is empty. If this dependencies array has a value, then it will rerun this effect when this value changed since the last time. And in this example, that will not happen because we're not this is a const. It can never change.
Okay.
However, if we're gonna extract this logic here into a reusable hook, let's just go ahead and do that now. I was planning to do that anyway. I'm gonna make a reusable hook called use observable. We're gonna pass in an observable. I'll just do any for now. I'm gonna try to go quick, so I'm not gonna bother with writing the types out correctly. And so I paste this in, and I'm gonna swap this guy in here as the dependency. This guy should be parameterized. I'm using this value. I'm actually gonna make this behavior subject for now. Maybe I call this use behaviors subject. Okay, for now it's use behavior subject. So if I wrap this guy up, then I can, use it. Oh, and I want to return just the value, I think. So the user of this hook can just write this, and that's pretty convenient. It doesn't like this. Oh, yes, I did mean that. So this is pretty convenient, and yeah. So this does the same thing, and we have a reusable hook for behavior subjects. What about if we want to generalize to an observable? I just didn't bother with the initial value and said initially it's null. So this is a reusable hook I have in this repository. By the way, this repository is on my GitHub. So if it's called React Hooks Examples. So you're welcome to, I just push my new example code in here, so you can go grab it and spin it up and play with it. There is a REST server that's bundled with this. Yeah, you can read the instructions and if you want to play with it. So yeah, so I made a reusable use observable hook that's like this. If you do want to, like, if it's a synchronous observable and you want to grab the initial value from out of it, there's a way to do that. Ilya and I did some work on that. So you can just subscribe to the observable once in the event that you can get the value synchronously, and then stick it here. I'm not gonna bother with that here because I want to get through some other material here. So this is a very simple way, basically, to connect basically the React hooks system with the RxJS system. One important thing to note is the cleanup process. I also put some code to detect for nulls, so I allow the incoming observable to be null. And in the case it's null, I don't actually blow up. I just don't do anything. And that's designed so that it's possible that if you want to just cancel the previous observable, you can pass in a null this time. And because the React host system remembers the cleanup function from last time, it'll clean up the last observable that was observed in the event that you pass in either a different observable this time or a null value. Not sure if that's really needed, but I put it in there for some reason. Okay, so that's observables. That's sort of like the basics, the most simple way to connect up observables with the React system. Any questions about that? Because next I'm going to talk about the aborting aborting fetch requests using the fetch API.
With that conditional logic you put, where you could pass null, is that like? Can you just quickly give like an example of what that would be? Like,
okay.
How would you want to do that?
Okay, so let's say. So first, let's say you have two counters for some reason. One that starts from 1 and one and you might want to, like, maybe there's like a toggle button or something. They want to toggle between the two observables. I want to go fast, so I might not build the whole thing out. But let's say you click the toggle button and then you're like, if something, then I want to basically switch the observable. Like basically when you toggle this button, it's gonna switch the observable to one or the other, and so this will not stay the same, right? And the cleanup logic is set up such that if the first time you pass in this one, that also registers the cleanup function for the first one. And then if you toggle and then the second time you render, you pass in a different observable, that's gonna call the cleanup logic for the first observable, so that the first observable gets unsubscribed. Does that make sense?
So whatever you return from the useEffects hook is like what React knows to use as the like what to call when it changes.
What to call when it needs to be cleaned up, and when it changes, when this changes, it'll call this effect again, and whenever it calls the same effect again, it makes sure to clean up the previous run of that same effect.
Okay, which is whatever was returned last time.
Exactly.
Okay.
And that's a very important thing about the life cycle of hooks. So with with my idea of passing in a null value for the observable would be like, else maybe you have some condition where you just want to pass in a null value, and you want to cancel all of the observables that you might have subscribed. So you just pass in a null value, and if that's the case, it will also have the effect of canceling or cleaning up the last one. That's
and then it won't establish a new one in its place.
Mm-hmm. Okay. So now I want to talk about cancelable requests. So a cancelable request, I learned this from wait, no, not yet. Let's talk about this abort controller mechanism that you can use with the fetch request. And I learned this from this David Wash blog post. But essentially, when you use the fetch API, you have the option of enabling a abort controller, and you wire it up like this. You first new up an instance of an abort controller. You could just do it. It doesn't require any special parameter or something. You just new it up, and then you wire it up into the fetch options that are passed as the second argument of the fetch API. And if you had and then you do your normal way of using fetch. You can await it if you're using async await, and then you await the JSON parser, etc. But what this allows you to do once you've wired this up is you can, at any point in time, you can call abort controller abort, that's gonna abort this request while it's in mid-flight, assuming it's still in mid-flight at the time you called abort. Okay, and that will actually cause the underlying request in the browser to cancel itself, and the status of that actual request will be canceled. And this is, I think this is slightly better than just ignoring the response when it comes back, because you can certainly do that. It's slightly better because, well, in the event that the data hasn't come back yet, you can actually abort it and cause the data not be sent at all, saving some network bandwidth, right? You can sort of like, well, there might be a lot of data coming through the pipe. Maybe there's a lot of to-dos or something, I don't know. And then that doesn't need to be sent now because you aborted it, and you're telling the network protocol at that level to stop the transaction. So that's pretty nice. With RxJS, if you're using Angular and you're using the HTTP client, it actually has that cancellation capability built in to their RxJS way of making requests, which is if you start subscribing to a code observable coming from their HTTP client API, and then you unsubscribe it, the moment the last subscriber, well, in this case, every new subscription costs a new request, I think. So it's not the last subscriber. But if you unsubscribe it, that's the moment it'll actually cancel the request. And we're actually going to do that a little bit later. So anyway, so there is this capability of canceling requests, and it's pretty nice, and I want to make use of this, right? We want to use this in our application, but this API is slightly awkward, so I decided we should make a cancelable request object that has this cancel method on it. So this is what that is. It's a very small class. We just make an abort controller first thing, and then you basically you use it like this. There's a little bit of example code here. You use it like this. You say new cancelable requests, and it gets the same parameters that you might give to a fetch request. You probably stick it into a class variable or some other kinds of variable, it doesn't matter, and then you say request.fetch, and that's when it actually starts calling the fetch API. But this request object also has a cancel method, so maybe there's something else that's happening in the UI that warrants this request be canceled, and to do that you just do this request.cancel. So that's the job of this request object. It just makes it easier for you to cancel a request, and then we're going to be using this in as part of the wiring of hooking it into the React system and the RxJS system. Any questions about this one?
I'm kind of confused about what the init property is doing.
Oh yeah. Okay. This init, yeah, maybe the name isn't great. Maybe I should call it like this.init. Oh, I defined that here. Request. Maybe I should call this fetch options. Maybe that's a better name for this. So it's the set of options that the fetch API accepts, and this request init type is coming from coming from the this is part of the fetch API. It's part of the standard. Fetch is a standardized thing into the browser. So this is just telling you what parameters can you give to fetch. These are all the options you can give. And the one we're using is the abort signal. So we're automatically inserting our abort signal, and then we're passing it into fetch. What's the matter here? Okay. Does that answer your question?
Yep.
Okay. So yeah, so now that we have a little bit more convenient way to cancel requests, we're gonna try to wire it up. So one thing I want to mention is I actually tried several ways of doing this. I had a session with Mike a couple of weeks ago. We went through an exercise of wiring it up a couple of different ways. Before this talk, I tried a few more ways. I'm not gonna show all the different experiments that I showed. I'm gonna show the ones I like better, but if you want to, you can check out this repository and look at all the versions that I gone through. This is one version that I let's see. Actually, let me show this version first. Okay. So first of all, let me show you when you run this example, and in this case, it's this one. Ouch! Did I just break stuff? I thought I saved this. Well, this stuff doesn't work, so. Come on. Okay. All right. I think this works again. Okay. So first of all, the thing I want to show is that if you switch this to this example component that I built and then switch off of it immediately, let's see. I'll just show you, so it's making this request, which is going to take 2 seconds because I configured the backend to have the request delay by 2 seconds. So it takes 2 seconds to come back. We're going to do it again, and this time I'm going to switch away before the 2 seconds is up. You can see the status of the request is canceled. So it actually told the browser to cancel this request. And now I'm gonna, and then if you click on try again, it'll make another request, and then this request will also be canceled if you happen to switch away before it completes. So let's look at this code here. So
if it weren't cancelable, would it have stayed in the network panel as pending?
If it were not cancelable, you would just end up waiting until it completes successfully. Or if you weren't canceling it, I should say. Yeah, you just end up with OK. But then when it actually comes back, you actually need to build a mechanism to ignore the retrieved request, and the response, I should say. You just need to ignore it, and because your UI is gone now. And okay, so this is an example of how you would wire this up from scratch. So this URL, I'm using it to instantiate a new cancelable request. I'm gonna use useState to. I'm just saying this request is a state. I found we could have used a ref for this, but I actually prefer using state for this kind of thing because I find the ref API very clumsy. There's not a convenient way to instantiate things. So I usually for things like this that don't really change, I just instantiate once. I use useState anyway with a lazy initializer. So I create a cancelable request, and then using a use effect, I'm gonna start the fetch process, and then when the data completed, I'm gonna call this set data from this use state to set the data so that this data can be used to render the UI. If there's an exception, I'm checking for the abort event, because if this cancel is called, which would happen if this use effect hook ended up cleaning up its pending request. This cancel gets called. It actually causes this waiting request to error out, and we'll end up with an error. So this is testing if it was the actual abort error that was generated by this cancellation. If it was, we're just gonna ignore it. But if it's a different type of error, then that's not the abort action. So we're gonna still throw that so that developers know about that.
Can you drill into the cancel method again? The request.cancel?
Can you you want to see this?
Oh, okay. It's
Mm-hmm.
simple.
Yep.
And where did that message you're matching come from? User aborted a request. Is that like part of the standard abort controller API?
I'm gonna delete this code and show you what would happen if I didn't have this. Let me see. I want to make sure I'm using the right one though. There's a version A and a version B. So this is version B. Okay, let me try this. Okay, I'm gonna wait for it to compile. Okay, so I'm gonna try version A. So if I let me see. I'm gonna look at the network panel. I'm gonna go here and then I'm gonna switch away from it. So it's canceled. You can see this cancellation. And what happens also when that happens is you get this uncaught exception in your JS console, which is fine for the user. They don't see it, but developers see this, and I don't want this to show up for the developers, obviously, because this is expected behavior. So basically, what happens is if you're waiting on this fetch, which is in reality over here. So like you're awaiting this fetch API to come back with a response. And while you're waiting for it, you get this abort. Then what actually happens is this line will throw an error, which is going to skip the rest of all of this code. It also includes, well, here we don't have anything else. But it'll cause this promise to fail with an error. And if it's an uncaught promise, you'll end up with like this big exception that says you have an uncaught exception. So to prevent that from happening, I catch it. But I want to make sure the one that I catch is this abort request. If it happens to be a different error, I don't want to ignore that because that could actually be a programmer mistake, and we want them to know about that. Okay. Okay, so I actually experimented with different ways of extracting this logic into a reusable hook. One way that I liked was this, where we have a reusable hook that's called use request, and then you pass a URL, maybe along with other parameters that fetch accepts as well. And then you also pass a set data callback into this hook, and the contract is whenever the request comes back with the data, it'll call your set data callback. And then it also gives you ability to retry. So it returns a retry function, and if you want to retry, you just call the returned retry function. So I felt like this is kind of a nice way to, but you still use your own use state to collect the data. So I'll show you the internal of this. So this guy inside the use effect, actually, I changed it to, instead, like the previous version, I had a state that remembers the cancelable request, but this one I just new up a new one inside the effect, because the cleanup will be done by this cleanup function anyway, so there's actually no need to put it in a state. So I new up a cancelable request, fetch it, wire up the ignore the error if it's a abort error, and then the setter is passed in. So when the data completes, I just call the passed in setter, and you can define what that does for you. And then I have this try number that kicks off. If you want to retry, you just increment the try number. And I stole this trick from the React hooks FAQ that uses this reducer to just keep incrementing a number. So you can just call this increment try number function to increment this number, and this number goes into the dependency of this use effect, so that every time this number is incremented, this use effect hook is executed again. Yep. So this is one way you can sort of extract a reusable hook for this purpose. Yeah, I think that's good. We also experimented with a more RxJS centric way of doing things. So let me show you that now. Okay, so first of all, let me see. Okay, first of all, we realized that in order to do it the RxJS way, we're gonna have to hand roll our own code observable object, which is done this way. It used to be that this was called observable.create. You might have seen like some tutorials. I might have done a talk about this before also. It used to be, if you want to hand roll your own observable, you use observable create. I found that they deprecated this. Create is deprecated. So the new way of doing it now is just new observable, but you get to pass in the exact same parameters. So basically what you do, it's actually remarkable how similar this process is to making a use effect hook, if you think about it. So let me put them side by side, actually. maybe we'll do the use. Yeah, I'll compare it to this hook here, to the make shared request. So the make shared request is, let me just talk about this for a moment before I compare. So the make shared request is a function. It's not a hook. It's not a. It doesn't start with the word use. So it's not a React hook, but it is a function that returns an observable, which will eventually give you the result of a request. So you pass in the request information, the same arguments that you would give to the fetch API, you pass into this function. And then this function just sort of hands it off to the fetch API, but through the cancelable request object. Okay, so here we making so this part is the content of here. Let me hide some stuff first. Okay, and you can forget about this pipe for the moment. So when you make a observable object from scratch, what you do is you pass in a function into this new observable constructor. And what this function is supposed to do is anything, if it's a code observable, it needs to start some sort of process. You just start that process. Just put in the code that would start that process right there and then, which in our case, that is this. We're gonna new up a cancelable request and just start the fetch process right away. Okay, and if we want to do this same error handling thing that we do for the other case, but when the data actually comes back, then we want to notify the observer that's observing our observable. So this observer will come once there's code that subscribes to our observable. You can think about this observer as a subscriber. So for every subscriber that subscribes to your observable, your callback is gonna get executed one time. So yeah, you can think of it as one call of my callback function serves one subscriber, and the observer is sort of a stand-in for my subscriber. So when the data I'm fetching actually completes and comes to me, I'm gonna notify my subscriber of that data by calling observer.next and giving the data to it, and then I'm gonna complete this stream of data for that observer. This complete is, yeah, it's like RxJS has a concept of completing a stream, the last thing that will ever come. So we're gonna complete this stream because that's how Angular HTTP client does it as well. There's only ever gonna be one data point in the stream, and then after that comes, it will be completed. So we're gonna follow their convention here. And then similar to the use effect hook in React, when you make a new observable object, you also return a cleanup function. So these two integration pieces of code look extremely similar, and that's because in many ways the problem that React hooks is trying to solve, in many ways it's the same problem that RxJS was trying to solve. They're trying to solve for a lot of the same stuff, so it makes sense that they have similar APIs. So we're gonna return a cleanup function to RxJS as well, and this cleanup function is gonna get called when the subscriber unsubscribes. So that's how that's why when you use a switch map to make a request, it will get canceled if that the result of that chain of RxJS observable things eventually get unsubscribed. That will eventually propagate up the chain and actually cancel that request. And by implementing this cleanup function, you wire that up to happen.
Hey Toby, so this teardown logic, like the return value, does this also get called if the subscriber calls cancel? If the observer calls cancel?
If the observer like subscriber can't call cancel. Cancel is not a method of RxJS observables, but unsubscribing is.
Right. Okay. Yeah, that's true. So we're calling, like, you're using the observer.next and the observer.complete, but there's also an observer.cancel available, right?
Is there? No, I don't
Aren't
think.
those the three things that are available on subscribers is next, cancel, and complete?
I have to be honest. I don't know about cancel. Is that an actual method on a subscription? Let me see.
On an observer.
On an observer, not a subscription.
On an observer, you can cancel like that.
Yeah, I believe so. Yulia, do you know?
I don't know.
I don't know. Sorry, I don't know this. So I would observer. Do they? The weird thing is there a type for observer? Oh, it's subscriber. Okay, we can drill into it, maybe if we can. So I don't know the answer to this.
I don't want to derail you too much, but the point is that whatever you return from the observable class is going to. You said that's the teardown logic that gets called when you unsubscribe, right?
Yep.
Okay, that's clear.
I thought maybe it's observer.error or something. Isn't it like
Observer? Yeah. Error is another part of the RxJS API. So, you would do something like actually I didn't do this right. I should have done it like here.
Mike is right. That's definitely what I was thinking of. Is observer.error, not cancel.
Yeah. So I should have definitely done this, and there's just something I missed. So if I want to connect the error condition in terms of RxJS, then I need to tell the observer that I encounter an error. So instead of throwing an error, I need to tell the observer about it.
Perfect.
By the way, there is a from fetch method, RxJS method that you can use just does exactly what Toby wrote.
Oh, seriously? Okay. Well, that's good to know. So, but it's good to know what actually happens inside, though, right? So you're saying there's a from fetch like that?
Yeah.
Oh, it's a from fetch. So you can do from fetch, and you put in a URL like this.
Yeah.
So it's like from event, but for.
Yeah, and it's cancelable right away. That's so.
It basically internally it probably looks like this. One thing I added is this share replay logic. So because one thing I am really worried about is code observables being observed by a reactive UI, because with a code observable, which this would be if I did not have this line here, this would be a code observable. So you use it like, well, I had the code that was using it. So you would use it like this. You say make the request, and then you would get this back, and that's the observable. If you had multiple subscribers to this same code observable, it would end up making the request for each new subscriber that you would have. And in our scenario, that would be like if you pass this down to your children components, for example, and they are observing this, like they are doing this inside of them as well. So you end up with multiple use observables on the same observable. And if that observable is code, it's going to make one request per one of these use observable hooks that you're using on it. So to prevent that, we actually want to buffer the data using a share replay. So a share replay, conceptually, you can think of it as you made a behavior subject, and then whenever this data comes back, you're just doing a .next on that behavior subject. And that behavior subject is buffering that data for you. So when you subscribe to it, you're subscribing to that buffer, not subscribing to the request itself, and therefore it doesn't send out another request every time an extra subscriber comes in. So this is why I had this like this. This ref count true is very important, actually, because the ref count true says if let's say if you have 3 subscribers on this guy, and then the ref count actually keeps that count. It's like, oh, 1, 2, 3 subscribers. It knows how many active subscribers there are. And if that count goes back down to 0, and that it takes note of that, oh, ref count is 0 now, and it would actually go back and cancel the request upstream. It unsubscribes to the code observable that was upstream, which will enable it to cancel, like enable it to call this cleanup function and thereby canceling my cancelable request. Yep. So I thought I like this way of doing things as well. This is another one of my favorite experiments where and this share replay is why I'm calling this guy make shared request. I'm saying this request is okay for sharing. If it weren't for this share replay, it will not be. So this share request, then we can just use this use observable hook to observe that data and then get access to the data, which can in turn be used in the UI. And a simple way to implement retry is just set this share request again. So now it's a new instance of the request, and that's gonna cause this observable thing to be a different instance. That's gonna cause the previous one to clean up, and then cause the request to be made again. So I kind of like this one. It's pretty clean. I made another one. I don't like this one quite as much, but this one is I start with a subject at the top of the chain and then use a switch map to call into this make share request, and then I'm like sending messages to this top level subject to trigger requests. I'm not sure I like this one. I think that this one requires less code. So, but this is a potential way that you could do it. And then I thought, what if you didn't want to go like all in with RxJS, but you want some of the benefits? So this is another way you could potentially wire this up. You could use a behavior subject to store your data in lieu of use state. And then you can think of it's sort of like interchangeable. Like you can, in any scenario, you might use a use state or you might use a behavior subject both of them do sort of the same job, which is to cache some data. They just have a different API, and maybe you prefer behavior subject because you're used to it, but both of them are doing the same job.
Hey,
So
Toby,
yeah,
what you said that you don't like the use ref clunkiness.
Mhm.
That's why you use state.
yeah,
What do you mean by clunkiness?
okay. Yeah, okay. I'm gonna take a slight detour, talk about that, sure. So there's this hook, if you're not familiar, called useRef. You have to import it. Okay, so you give it a initial value, but you're not allowed a lazy constructor like this. And the way you, but when you want to set a value, first of all, you access the value using this myref.current. I should probably preface this by saying useRef, they tell you that you can use useRef similar to the way you use instance variables in a class. But and as long as you don't need, as long as your UI is not tracking changes to this value, it's okay to use a ref. So the way you typically use a ref is like you instantiate a ref, but then you can't set, like, if you want a lazy initialization like this, like, it's hard to do. You would have to do it inside of a use effect, I believe. You do it like this, right?
Well, can you use use memo?
use memo to calculate this like that.
No, like you can, instead of use ref, you can do like use memo and initialize it lazily, and then you also don't have to do .current because since it's always the same idea anyway.
But use memo doesn't guarantee that it's only ever gonna instantiate it once.
Oh yeah, that's true.
It's not, whereas the useState lazy function does give you that guarantee. So I just feel like I just prefer this. It's like, yeah, maybe I can build some sort of infrastructure to get rid of this clunkiness, but I feel like this is fine for my needs. So I prefer to do this for just setting up like one-time initialization kind of thing. I like this useState with a lazy initializer function pattern. Okay, so anyway, so this pattern is another one that I kind of like, which is just, if you like using a behavior subject, I guess one thing about behavior subject that's, I think, is nicer than using a normal use state is that once you have this behavior subject, because it's an observable, you can pass it down to your children, and then your children can just work with it as an observable, and there's this convenient use observable hook that can just allow them to sort of work with it in a very convenient way. It can definitely be done with a normal use state and the normal React hooks stuff too. It's up to your preference, I think. But anyway, if you did this, then you can use a use request hook like this. This is the same one that I showed earlier, and you pass in a setter. But the setter would just call your .next to supply the data to your behavior subject, and then you turn around and use this behavior subject, and then to sort of unbox the data, and then there's the data. You can use it in your UI. Okay. There's some stuff that I omitted. I didn't have time to go to, or it would probably take even longer to go through. So there's some stuff that I haven't really solved, or at least implemented in this code. One of them is error handling. I haven't totally addressed error handling. Like if we want this thing to work with errors, we might pass in another error callback function, perhaps, to allow the outside to handle errors correctly, or because RxJS has its own error handling mechanism, there might just be, a wiring up of a behavior subject or any observable. Perhaps you pass in an observable, and it'll wire up both the streaming of the data and the error handler correctly. That's something I think that could be done in a nice way. Another thing that I have not tackled is I see in a lot of the code, in AutoWash and in all the projects really, but in the Angular projects as well, where you want to combine, or you want to make a number of requests up front, and you combine that into one promise, or you combine that into one big observable. I haven't explored into like what's a nice way of doing that. It depends on whether you go a more RxJS route, or you go a more React hooks or promise-based route. So that's another area that we can explore more in the future, and I'm sure like you guys have explored that as well, just in your daily work. Okay, any questions or comments? Okay, yeah, that's all what I have for you. I'm also open to requests if there's topics that you like me to cover in the future. Just let me know. Thank you.
Thank you, Toby. Very cool.
Thanks, Toby.
Alrighty. Talk to you guys later. Bye.
See you guys. Yeah.